Alrighty, we're gonna review a little factoring for today. Um, so we got some of the worst types here that people seem to make the most mistakes with. So we got quadratic where a is not 1. So for these, you have to use the AC grouping method here. So our AC value is going to be 14. And we need to find factors of 14 that add to a 9er, which we'd want to use 7 and 2. From here, we rewrite that middle term. So we keep this the same. We rewrite the 9x as the 2 and the 7. So 2x, 7x plus the 7. And then we go ahead and we group our first two and last two together. This is that grouping part of this. Out of each of these, we pull out the GCFs. So if we take a 2x out of here, leaves with x plus 1. Take a 7 out of here, also leaves with x plus 1. That's a good sign because these parts should always match, and they do. So now what's the factored form look like? Two GCFs come together to make the one factor, and the two common parts come together to make the other. So there we go. There's our factored form of a good AC grouping factor. Number 2, my favorite, difference of squares. I like difference of squares because, in my opinion, it's simple. But there's one like this on the quiz people got a little weird with, and I just tend to see people make some strange mistakes here. So you look and say, what would I multiply together to get this? Well, this would be 3x times 3x. What would I multiply together to get this? 6 times negative 6. Those are going to be our factor pairs. So we're going to have 3x plus the 6 and 3x minus the 6. And that's it. Don't do weird stuff here. You're not cutting them in half. They're squares. The 3x times the 3x gives the 9x squared. The 6 times the negative 6 gives the negative 36. And the 18x and the negative 18x cancel out. That's why it works. This one, a little bit sneaky here. We throw a quartic, but it's in the same format as a quadratic. So we can actually use our factors of C that add to B type of moves here, because A is 1. So we could say factors of negative 18 that add to negative 7. So we go negative 9 and 2. And the fact that these are x to the 4th and x squared is going to work just fine, because what it's going to be now is we're going to say it's x squared minus 9 and x squared plus 2. Which is good. Like, this actually still works. It still makes sense. It's just treating as if these were x and x squared. If they're x squared next to the 4th, it actually still will multiply out and give us the same thing, because this will multiply to give us the x to the 4th. This will give us the 2x and the minus 9x to get that term. And we're all good. So now the thing with this is you can factor a little further, because yet again, another difference of squares right here. So this can be x plus 3, x minus 3. And this is a sum of squares. It's going to have imaginary factors. So, you could call it x plus root 2 and x minus root 2. But when they're roots like that, we usually don't bother with factoring it. So we can just leave it in this form and consider this the completely factored form. So we're going to see a lot of this going forward. So just a little brush up on factoring here.